So today's lecture is of gravitational potential energy. So we will be talking about what gravitational potential energy is and its properties. So the gravitational potential energy of a body at a point is defined as the amount of work done in bringing the body from infinity to that point against the gravitational forces. Now, in this case, again we would be considering a bigger mass of m and a small mass of small m, and the distance between them, let it be r. Now, as I said, it is equal to amount of work done in bringing the body from infinity to the point against the gravitational forces. Now, this will be work done integration over infinity to r. That's what definition says. Gmm x square dx with respect to dx. Now when I differentiate this value, I get minus gm 1 by x r infinity. So it will be minus gmm 1 by r minus 1 by infinity. So it will be minus gmm over r. Now this is the work done that is stored inside the body as its gravitational potential energy. It can be written as W or it can be written as U because it is a gravitational potential energy. Now, moving on to its scalar, its properties. Its properties are potential energy is actually a scalar quantity. The next thing is the unit. Unit of work done is that is joule. And if I write its dimension, it will be m L raised to power 2 T raised to power minus 2. And one more thing is that the gravitational potential energy is always negative because the force is always attractive in nature. So always the work done or the gravitational potential energy is in negative quantity. Now, as you can see that the distance between two objects is inversely proportional. That means if you increase the distance between two objects, the gravitational potential energy becomes less negative. That is, it increases. So if I say the next condition, if I say that R is infinity, then it becomes 0. U will be 0 or W will be 0. Now if you want to write it into a discrete contribution manner, so it will be U equal epsilon ui equal minus gm1 m2 r1 2 plus gm2 m3 r2 3. So this is how you will denote it in discrete distribution of masses. Now the next thing we need to find is the relation between gravitational potential energy and potential. So as you know that G is given by minus gm m over r. So can we write like this? Positive m minus gm over r. Now you know that u is equal to m and this value is nothing but v, the potential. So the potential energy, the relation between potential energy and potential is u equal mass times potential. Now the next thing, we need to find gravitational potential energy of a body at height h from the Earth's surface. So potential energy of a body at a height h from Earth's surface. So as you know how to define U now, so it will be gmm minus r plus h, because whenever we have a potential energy with respect to height, we need to consider extra h here. So it will be r plus h. So here the equation is, and now we can equate the value from this, like you know that it is equal to g r square m over r plus h. So we can write it as mg r plus 1 by h plus r, because we would be taking r common from here. So it will be mgr over 1 plus hr. So that's the end. I would be coming back with some examples for the same.